Welcome to Slope Reliability, the show where we learn about reliability, observability, and resilience one day at a time. I'm your host, Stephen Townsend. Welcome back to Slope Reliability. I'm Stephen Townsend, and this is the show where we learn about SRE and observability one episode at a time. Today, I am joined by Krishna Vinnakota. He's a senior site reliability engineer at Microsoft. He has 20 years of experience in the technology industry and has worked in various roles as an SRE, a systems engineer, and as a software engineer. He's worked on multiple large-scale products such as Azure Cosmos DB, Microsoft Teams, Xbox, and TikTok. And he's previously worked at companies such as Amazon and TikTok. How are you going this morning, or this afternoon for you, Krishna? How are you going?
Hey, Stephen. It's going great. It's great to be on your show.
So you currently work at Microsoft. Tell us a little bit more about yourself.
I'm working as a senior site reliability engineer at Microsoft. I work on this product called Azure Cosmos DB. It's a large-scale NoSQL distributed database, very critical. Like a lot of critical customers use this service. I work as SRE, like I deal with a lot of SRE stuff with on-call, alerting, automation, root cause analysis, like working with different product teams to make sure things are going live with reliability. And previously I worked in different groups at Microsoft. I worked on Xbox and Teams and Dynamics. So I also got a chance to work at TikTok for a couple of years in between. So that was a cool experience. I've been in Seattle area, living here for the last 16 years. So it's a pretty cool area. I have 2 kids.
Oh, fantastic. So we thought today we'd talk about the topic of alerting, which is pretty timely for me because it's a thing we're continually trying to show. In fact, right now, one of my engineers put together a draft set of guidelines for alerting for our company. We don't have any standards around alerting. So we're thinking about things such as everything from the tooling, because there's been lots of different tools in the past, and now we're consolidating into one. When to alert, the different priorities of alerts, what to do with them, what a good alert looks like, everything. So this is a great conversation. Is alerting a big part of your daily work?
Yeah. I think SREs are kind of best positions to deal with alerting. I mean, if we are working on a large scale, very critical service, alerting, like getting the precise signals about the health of your service is extremely important. Because to uphold your SLAs and SLOs, you should be able to know if something goes wrong in your service. You should be able to know pretty quickly, and then only then you can do some action. Either it could be through automation or someone just getting paged and then reacting quicker to restore the service, right? So SREs are actually best positioned to do that because they know the breadth of the service, and then they work in different layers of the stack. And then in general, I spend in that way, I actually spend a lot of time in my day to get these precise signals, right? Like configure these best practices for alerting, etc.
We often use the term alert noise for when there's lots of alerts hitting us. So I'll sort of describe what I think alert noise is, and you tell me if I'm on the right track. I think alert noise is basically when there's a large amount of alerts coming, which don't actually tell you about a real thing that you need to act on. And or alternatively, there's just so many alerts hitting you that it's too much for you to keep up with, and it blows your brain out. And you're like, is that kind of what alert noise is?
Yeah, correct. I mean, that's what it is. So basically, on-call engineers, they're already kind of stressed about getting alerts in the middle of the night, right? If you are bombarding them with non-actionable alerts, any non-actionable alert can be defined as a noise, right? Because when an alert comes, there should be some specific action that someone needs to take. If there is no action, you can consider it as noise. If there are too many of these, and on-call engineers, they get bombarded with these non-actionable alerts, there are 2 risks, right? One is the real issues will not get the attention that they need, and that in turn impacts your customers. When you're running such a critical service, these impacts will have significant downstream impacts for the customers. So that's one very negative effect of these non-actionable noisy alerts. The second one is engineering hours are valuable. So if you are wasting on-call engineers' time with these non-actionable alerts, so you're just, it's very demotivating as well, right? As for engineers, you just get an alert and you see, okay, it's not actionable. You waste some time looking at that and then just move on. So those 2 are main things that impact. They'll have impact because of these noisy alerts.
A little bit another aside, there was a conversation on the SRE subreddit recently. Someone was saying, more than one person said that every alert should have a link to a run book or some kind of starting point for investigation.
Yes.
Do you agree with that?
Yeah, totally. Every alert should have a run book, a set of instructions or troubleshooting guide or a run book where what specific action that you need to take, the on-call engineer need to take, and also some other information as well, right? Like what is broken, why is it broken, at least some of the information, and then links to different dashboards where you can see the health. I mean, because getting the alert is one thing, and then checking the status of your service, there should be a way to check the dashboards quickly to identify whether once you execute the runbook, you want to be able to quickly see whether whatever you have executed has actually helped with reducing that issue. So there are certain things that have to be in this alert, so that all these points will make these alerts very highly actionable, right? So that's the goal, having those alerts.
I remember 6 months ago, we had there were different alerts going to different channels. One of them was email, actually.
Yep.
Email teams, also tickets being created. Yeah, so we were getting hundreds of alerts every day. We've reduced that by about 75%. But I guess my question is how, and I see it now, we have stand up every morning, and almost every day someone is talking about a particular alert and wanting to tune that alert because it's like, oh, it's going off. Actually, you don't need to act though. How do you design, or because you know what happens? Engineers go in and they build an alert and they make these decisions at the moment. How do you make the right decision about what threshold to set the alert for or what to alert on?
So that's a great question. So it all comes back to your SLOs, right? Basically what you are trying to measure, and then getting that threshold is kind of like art and science, both. There's no single answer of like, this is the right threshold for this alert, right? It depends on like what would be the impact of that. Say if you have, just take a basic example of CPU usage, and if your service may be okay if it reaches the CPU is running across the cluster at 80%, but you want to be able to alert it before it impacts the customers, right? There is a negative impact on your SLOs. So do you send the alert at 60% or 50% or 70%? Those that's depend on various other factors, like how long will it for you to take some action. Say if your traffic is increasing and you're expected that the growth of your service will increase, and it will take some time for you to get additional capacity if you need to, for example, right? And in that case, you may want to alert sooner than later, and a lot of these factors. And then you have to play around with these thresholds also, like what will be noisy, right? And again, if you are optimizing your infrastructure capacity to be running at 50%, you don't want to be alerting at 40. That will become noisy. So there is a sweet spot between where it becomes noisy and where you want to catch the signal before it becomes issue. So that's why I call it as an art. And there are a lot of these signals, right? I mean, error rates and different kind of signals may have different threshold that you want to alert. And again, having the process set before you deploy these alerts into production is important too. You have to treat these alerts as your production code. The same rigor needs to be applied for these alerting configurations too, right? I mean, I don't go right away and then say, okay, I feel 40 is the right threshold. I just go and deploy that alert, and then suddenly you have hundreds of these emails or alerts. There should be some rigor, meaning you need to be able to test these alerts before you deploy to prod to make sure that you are avoiding the false positives and false negatives. So there is a sweet spot between that threshold, right? So you play around with those thresholds, you test them, you create pull requests as you do it for any other code change. You get it reviewed by at least one or two people on your team. So have these CI/CD pipelines that validate certain things for these alerts, and then finally deploy. So having this process, like a set process, applying the same rigor as you apply for your production code, would significantly improve the quality of these alerts. So that has worked for us, and that's what we follow here in our team, and that actually worked pretty well. It's an ongoing problem. I mean, it's not that even if I do that, there's no guarantee that I'll not get noise, but the probability of getting these noisy alerts and getting false negatives, that will reduce.
That's awesome. Yeah. We don't test our alerts at the moment, but that obviously different scale company, different context. But that sounds like something I think I'd love to do. Yeah, treat it like any other production code. I've seen in certain situations, some organizations, if their observability is fairly, I'll use the word immature, but like early on in the observability journey, then you may be trying to alert on events and logs. Like, this thing happened, I'm going to fire an alert. That's not the way to go. You've got to get to like to go from that event-based alerting to like metric or signal-based alerting. I think that's also important. But something we talked about a couple of weeks ago is I asked you, well, why don't you just alert on SLOs? If the SLO is broken, we need to do something. If it's not, don't worry about it.
Ideally, that's what you would want to do. But I know like SLOs have a slightly lower threshold than your SLAs. You promise certain SLA to your customer. So you have like a higher bar for your SLOs. Maybe like the approach you told could be, it could work in some cases, but it may not always work. For example, like golden signals, right? If you take the golden signals, the last golden signal is the saturation. Is saturation tied to any specific SLO? May not be directly. But if you leave it unchecked and then if you don't alert on those, you will definitely at some point like impact your SLOs. So you may still want to get alerted even before you breach your SLOs. Because like say, again, depends on the workload of your service, right? Because certain workloads are sensitive to CPU usage. Certain workloads are sensitive to disk I/O. So we don't need to alert on every single like saturation signal. But whatever is critical for your service, having like alerts for those also will help. So on a high level, you could have like majority of alerts for SLOs. But again, like there are like other signals that provide valuable insights before they actually impact your SLOs. So creating alerts based on SLOs may not actually always work. At least in our case, it doesn't completely work. So we'll have to have like some other signals too, which are like, we for sure know that like they will impact the SLOs, right?
Yeah, it makes total sense. And I've recently been doing some work to understand and how we deploy. So we look after a observability platform. It's the open source Grafana stack, Grafana, Mimir, Tempo, Loki. The open telemetry collector is our gateway, and it's hosted in ECS. And like we need to monitor this thing like any other application. I realized straight away we can't just have SLOs. We actually need to know if the CPU goes too high or if our containers are not up. We need to
correct. I mean, if certain percentage of your nodes or the VMs are like whatever pods or nodes are infrastructure is down, then you also have to be alerted, right? Those may not have direct correlation to the SLO, but they will eventually impact your SLO. In those cases, you would want to alert on those also.
Talking about saturation, so obviously CPU consumption, you mentioned disk I/O. Are there any other like common saturation signals that you monitor and alert on?
So I mean, on a high level, like CPU utilization and then disk usage, memory utilization, and network throughput in some cases. So those are the main like categories. Like I mean, those are the categories where the system will have some bottleneck. And disk usage versus I/O also, right? Disk I/O. And so if you are running a database and then disk I/O gets important as well. And then disk utilization also. If you are running out of disk space, then that's going to cause like a downtime for a customer, like if you don't properly act on them. So those are some of the signals that we measure.
I've often wondered about like queue length. If you've got queues and they get to a certain point, I don't know, it's not really saturation, but it's something that you might want to keep an eye on.
Yes.
So you were saying that we should treat our alerts like production code, test them somehow, have some rigor, have some automation. I guess if they are production code, then you need to maintain them and evolve them and work on them. Is there something that you do, and does it take is it a significant part of your work, or is it refining and improving?
That takes some amount of work on a continuous basis, right? Because I mean, every alert may have like some history behind it. I mean, it could have been created because you launched a new feature, or it could have been because there was an incident where you didn't have that alert, so you created that alert based on a postmortem. Some history is there. And then again, like the production systems, they evolve over a period of time. So they are not like static systems, right? They change. And whatever assumptions that we may have used while creating these alerts may not be true. and then they could turn into noise, or they could actually the thresholds might become too relaxed. Then those assumptions may not be valid. So that's the reason, like, having certain regular process of reviewing them, tuning them is pretty important. Like, one example is, like, say, if I have a weekly on-call schedule at end of the week, we can just look at all the alerts that got fired. And then on-call engineers, they may not actually have the time to go and fix like these thresholds. So they can just mark them as noisy. And at the end of the week, we can review like what happened during the last week on call and look at like signal to noise ratio, right? And whatever has been marked as noise, or no one has taken any action on them, reviewing them, at least like take like a couple of them every week and then tune them, right? Looks whether the threshold the assumptions are still valid, or do we need to disable or change the threshold. So those are like, that's a continuous ongoing process, because like these production systems are like living organisms. They evolve over time because various changes go into them, and customer like traffic patterns change. So based on these things, like it's better to review them periodically and tune them. So that actually helps you, again, the probability of like getting noisy alerts and then missing important alerts will also reduce.
Do you always alert on a single signal, or, like I'm going to alert when CPU goes above a certain thing for a certain period of time, or do you have any more kind of complex kind of alerting, which like means under these different conditions at the same time, then, that kind of thing?
It's a combination. Both are true. So there are certain, for example, like a CPU, we know that like for certain applications within our service, CPU is pretty important. So that itself alone will give enough signal saying that like someone has to act on it. There are other cases where you combine like multiple signals. Only one signal may not actually be impactful, but if you see, say, for other service, it's okay. CPU goes to that level, and you also start seeing like some increase in errors. It may not actually reach the threshold of SLO8, but combining those two will improve the accuracy. And again, there are other signals also, right? Maybe like certain cluster is getting decommissioned. So even though like the error rates are going up on that cluster, if it is getting decommissioned, you don't want to get alerted on those. So looking at another signal saying that, okay, this is decommissioned, or this is like in live. So mixing these signals would definitely improve the accuracy of the alerts. So, the answer is like, yeah, we have like both versions. So like certain signals, you are pretty clear that, okay, this is going to impact. Certain signals, they won't actually give you a right answer by themselves. In those cases, like just combining those signals would improve the accuracy.
Right. Okay. Kind of reminds me of, aggregate SLOs, maybe, where you've got an SLO that's combined of a bunch of smaller indicators.
Mm-hmm. Yep.
What about, because our services at the moment don't tend to be real time 24/7. So sometimes we'll actually need to have a maintenance window, or whether it might be down, and then all our alerts ping because like maybe they're bringing down servers or containers or whatever it is. What do you do in that situation where all your alerts are firing, but there's nothing to worry about?
Yeah, so that's a great point too. Like that's why having a mechanism to suppress the alerts, right, for a period of time. I mean, as you mentioned, there could be some maintenance going on, or there is some known issue that like some team is already working on deploying a bug code fix for that issue, and then meanwhile you keep getting these alerts. So that's why having a mechanism to suppress the alerts is like extremely important, extremely useful also. Like, we have like those mechanisms basically to suppress alerts. We know certain conditions, although it's impacting the SLO, but there is a reason behind it. And there is and customer is okay for that also, right? And customer could be okay for some time for that condition to exist. And in those cases, like suppressing alerts, some mechanism to suppress these alerts is important. So you address the problem by having the mechanisms to suppress the alerts.
Yeah, got me thinking right now. How can we do that in our situation?
Yeah.
Because our alerts are being generated in at least 3 or 4 different places. And so you need to think about in each situation and each different tool.
Yeah, another point I wanted to talk about was automation, using automation as the first line of your defense also, right? So we use that. We have automation, like before paging anyone, automation takes some action, waits for some time. If the condition that it is taken action for is not mitigated, for say last another 5-10 minutes, only then page an engineer, right? Because like when we have huge fleet of infrastructure that you are running on and huge scale, it's pretty quickly becomes like unmanageable number of alerts if you don't like use automation for mitigations. So like any, say for example, CPU is high on particular node, you may not actually need to page someone. Your automation can restart a process and then wait for some time. And again, like so have some checks and balances to for those restarts also, right? You don't want to just go and randomly restart like the whole fleet accidentally. So I think having the checks and balances to how many restarts that you allow during a window of time, having those checks and balances, and then automation taking care of like all the low hanging fruit. It could be restarting something, or it could be taking something out of rotation or applying some configuration. So all these things, basic things, can be applied through automation. We could create tickets with a lower severity, which don't page anyone. Automation can run it and then update the incident also, right? It could just close the mitigate the incident. At least there is a track. I mean, or you could just log it into the log system where you can look back and see how many actions were taken by the automation. And only if those common mitigations don't help and someone has to go and investigate further, only then you would page someone, right? I mean, and there is like a specific either action with book or like some defined escalation procedures also. Because like not everyone in the on-call rotation may not have like all the context about the service, but like at least information of like whom to reach, like what are the contact details, all that stuff should be there. And yeah, automation and using automation is kind of like lifesaver. It will definitely reduce the number of incidents that you would get by a lot.
And I guess another even sort of simple thing that your tooling can provide is that if a bunch of alerts occur all related to the same event or situation, you don't want all thousands of alerts for the same thing. You want them
correlate. Yeah, so you basically correlate them. And again, for the same condition also, right? If you create an alert and then you don't have to create the alerts for the same issue again and again, or like for the same condition across different clusters as such. There's like having these correlation rules, like you correlate somehow saying that, okay, these are all the same situation. And then if you have the right severity incident that gets created, that's all is needed because that gets the attention anyway. So there's no reason to just like page for like 100 times for the same issue.
So because I've read the book Observability Engineering, it talks about how maybe in the past, we had systems that were so simple enough that a lot of the time when things went wrong, it's something that we had maybe happened before or we kind of knew about. Now with our extremely complex distributed systems, most of the time an incident occurs, it's a brand new thing we could have never have predicted, an unknown, right? Yeah. So how can we possibly build alerts to help us prepare for that?
Yeah. So that's a great question. I mean, a couple of things, right? Couple of things come to my mind. One is the chaos engineering techniques that you can use. These are planned downtimes or like a planned random outages that you cause in your infrastructure in a controlled way. So that way, like if there are certain side effects that you are not anticipating, those can be observed and those can be dealt with. Again, there could be incidents, right? I mean, production outages as well. And you may not have seen certain signals within your alerting. Typically, if there is a customer outage that occurs and having the postmortem process will help you find out these, like asking the 5 whys, right? What happened? Why has something happened? The 5 whys. And then also making sure that like all the alerts that were supposed to fire during that event were fired or not. That's the unplanned version of it, meaning like you are discovering these with outages. That's why like don't let any outage go wasted, and then have like some repair items through the post-mortem process and then prioritize those to fix those situations, those conditions. And also chaos engineering techniques that you could use, like have introduced random failures in a controlled way in your production to catch these outliers. Maybe your like whatever you have accounted in your alerting strategy may not actually be complete. Like if you combine these two, like that will also help like identify some of those unknowns.
I think I like about game days and chaos engineering, chaos testing is like even if the exact situation that you're like working on never happens again, you're still building that muscle memory. You're still practicing as an individual engineer and as a group of engineers. How do we work together to respond to the unexpected. So I think there's heaps of benefit no matter what you do.
Yeah, exactly. I mean, that's pretty important as well, because when you, without practicing like some of these situations, going into outages may like become stressful also. And again, like we want to build these muscle memory, just like do. And again, SREs are best positioned for these scenarios. And if such a big outage happens, like the first ones that all jump in is like SREs, and then leadership, maybe the leadership would be there in those bridges, and we are driving everything. And then having these game days and practices is, I totally agree. Like those are like very valuable.
So we're coming up to time, and so I wanted to finish with a question that I haven't prepared you for. Which is, let's say there's somebody out there and their team, their SRE function is just drowning in alerts. They're just getting smashed every day. Where could they begin to sort of get on top of this and get their signal to noise ratio down again?
Yeah, that's great question. Again, like some of these things that we already talked about. I mean, you could start with marking those incidents, right? Like which ones are actionables or which ones are not, and like in some way ruthless about like disabling certain things, right? That are clearly not. Take top N and alerts, like how many by count, right? Take by count and then prioritize from the top. I would like just go at the top offender and then see whether that is actually, that alert has some value in your environment or not. If not, like why is it like not valuable? Is it like the threshold is too generous? I mean, is it like you need to kind of like have a higher threshold for that alert? Or is even the alert itself is valid or not? Like what is the history of that alert? Like why was it even created? So maybe just grouping those by the count and then going after like the highest offenders first and then burn down the list. And that's a great starting point. I mean, you would also, that actually will give you understanding of like, okay, what alerts actually exist, and then like whether these are like, do you want to have them or not? Prioritizing through that list would be the starting point.
All right. And last thing, is there anything else you wanted to cover related to mastering alerting?
Yeah. So another like important thing that I would say is constantly like upping your own knowledge about your service, right? Because when you have these complex systems, it will take a long time for you to gain like deeper and then wider understanding about that service itself. So it's a ongoing process. So like basically like you may have, when I joined the team, I only have like a limited amount of knowledge about the service, but every day like trying to expand my own knowledge wide and deep. That's the art part that I was talking about, because like science is like you have like all these best practices, PRs and testing, like all that you can do. But the art is where you understand the criticality of your service and like how different components interact and which parts are more critical than the others, and like working with other engineers within various different teams. So that will significantly improve my own knowledge and then help me become a better engineer. Also, it in turn like actually helps you to craft your alerts like with much higher accuracy.
That's great advice.
Yeah.
Well, thank you so much for coming on the show, Krishna, and chatting about alerts. I'm 100%, as soon as this is released, going to share this with my team and say, listen to this, because this is all super valuable, super relevant for our team and what we're doing. So thank you so much. Hope you hear
that. Thank you. Thanks for having me on your show. Like I've been like following your show for quite a bit of time, so it's actually great to have you on your show and then talk to you.
And for everyone else out there, hope you have a wonderful week or two, and I'll see you next time. Bye.
Yeah, see you. Thank you.